Okay, installment 3. Just a little bit of stuff to go over about choosing effective graphs. Now, all these graphs I have as examples are just as visual examples. They're not perfect. The titles are very brief and they have some flaws here and there, but you know, these are just different bits of images that I found on Google Docs and stuff like that. Or sorry, on a Google search for images and things like that. So I did my best in order to sort of show you what the most effective graph is for you to use. Okay, so certain graphs, of course, it doesn't make any sense for you to use. You certainly wouldn't use a histogram for categorical data. Okay, and again, the types of graphs you use for grouped or ungrouped data, and the type of graphs you use for categorical versus discrete, and the types of graphs you use for frequencies versus relative frequencies can all be different, right? But they can all be used the same way, or generally the same way. And there's sort of 3 basic versions of graphs you're going to see. You're going to see circle or pie charts. You're going to see bar graphs of some sort, or histograms. Excuse me. And then you're going to see either stem and leaf plots, or you're going to see pictograms. Okay, and really bar graphs and stem and leaf plots and pictograms are all kind of the same thing. You just turn it sideways and it's a bar graph with pictures, images. Okay, but for categorical data, we tend to either use pie charts or bar graphs. Okay, and to some extent pictograms, where each picture actually shows a specific number corresponding to it. For discrete data, pretty much the same spectrum. You can use all 3 of those types of graphs if you want to, but the bar graph tends to dominate and it tends to be the best to use. All right, and it's a bit more professional than using these pictograms. And the pie charts, it's very difficult to assess different numbers compared to each other, although they all tend to be labeled as well, but we might as well just have a frequency table for that rather than having a pretty pie chart. It does give you a representation, but if the values are all similar like this, then you're not going to notice any differences in here because all the pie sizes are going to be the same and you're going to be focusing on the numbers. Whereas here it kind of shows you inclines and declines. So we tend to use bar graphs. Key feature: spaces between the bars for discrete data, because there are spaces between the intervals. Okay, now this is for years. You shouldn't be doing that because years are actually discrete or continuous values because it's time, but that's neither here nor there. Again, these graphs aren't perfect. But for continuous data, the bar graphs that we use are these things that are called histograms. So you'll notice there's no spaces between the bars. Okay, so for histograms, in this case, it's the height in feet. Okay, and you'll notice, well, there should be a break in the axis here. Again, there are flaws for bits and pieces of these graphs. Okay, but this is an example of something called a histogram. This is another example of a histogram, but also one thing that we tend to do is we tend to take the midpoints of all these different bars and we tend to connect the dots. And when we connect the dots, it kind of forms a bit of a function. Okay, for those of us who remember grade 11 all the way downwards, we have functions. So this is a function. It shows the overall sort of shape of the distribution. And as a result of that shape to the distribution that we see, we call those polygons, mostly because they form these many-sided shaped objects that we can shade in. And there are a lot of features that you can use these for, especially when the bars get really, really small. You can actually approximate them with a function and then use the area under the function to figure out frequencies and things associated with those. And we'll do those in our very last unit. Okay, but a histogram for continuous data, or a frequency, or a polygon. Now, you can either do frequency or relative frequency or cumulative frequency. It doesn't make a difference for all of these diagrams. Okay. One final thing to notice for discrete data versus continuous data. Discrete data, we have gaps between the bars, and for continuous data, we have a histogram where we don't have gaps between the bars. So keep that idea in mind when you're choosing an effective graph. Don't forget, you want to make sure that you have a good title. Your axes are labeled. Okay, obviously the data is plotted correctly. Okay, and then your graduations or your gradations on your axes are appropriate as well. Okay, when you're constructing those graphs. So get to the homework. It's fairly simple, straightforward. You may have some questions. Make sure you direct those to me. Thanks.